Date and location. The largest tornado ever recorded took place on May 31st, 2013, in central Oklahoma. This region is part of what is known as Tornado Alley, a stretch of land in the United States where conditions are ideal for tornado formation due to warm, moist air from the Gulf of Mexico clashing with cooler, drier air from the north. On that late spring evening, a powerful supercell thunderstorm developed and eventually spawned a tornado near Reno, a small city located just west of Oklahoma City. Within minutes, what began as a relatively normal storm turned into a record-breaking event that would shock meteorologists and storm chasers alike. Size of the tornado. At its maximum width, the Reno tornado expanded to a staggering 2.6 miles, 4.2 kilometers across. This size is almost impossible to visualize without comparisons. Imagine standing in the middle of the tornado's path and seeing it stretch from horizon to horizon. To put it in perspective, the island of Manhattan is only 2.3 miles wide at its broadest point, meaning the tornado was even larger than one of the world's most densely populated urban areas. For people watching from a distance, the tornado's massive structure made it difficult to distinguish where it began and ended, which added to the danger because it didn't look as threatening as smaller, more defined tornadoes. Wind speeds. The measurements from the mobile Doppler radar showed that the winds inside the Reno tornado reached speeds of up to 296 miles per hour, 476 kilometers per hour, which is one of the highest wind speeds that have ever been recorded on Earth. For instance, the maximum speed that Formula One race vehicles are capable of reaching is approximately 230 miles per hour, and even then, they require specific tracks to reach those speeds safely. In addition to tearing asphalt off roadways and turning even enormous vehicles into lethal projectiles, these strong winds have the potential to demolish entire homes. According to the official assessment, the tornado was given an EF3 rating on the enhanced Fujita scale, which is based on the damage that was witnessed. On the other hand, this classification is not accurate because the most powerful winds did not directly hit any buildings. It is generally agreed upon among meteorologists that the tornado would have been classified as an EF5, which is the highest potential amount of destruction if those winds had struck populated areas directly. Path and behavior. The tornado's path covered around 16 miles, 25 kilometers, before it finally dissipated after about 40 minutes on the ground. What made this tornado particularly dangerous was its unpredictable behavior. Most tornadoes move in a somewhat straight and narrow track, but the Reno storm shifted direction multiple times and rapidly expanded in size. At one point, it doubled its width in less than a minute. This made it incredibly hard for storm chasers, researchers, and residents to anticipate its movements. Adding to the danger, heavy rainfall around the tornado created what meteorologists call a rain-wrapped tornado, which made it nearly invisible at times. Many people could not even see it approaching until it was too close to escape. Fatalities and injuries. Despite Oklahoma's advanced tornado warning systems, the Reno tornado still resulted in 8 deaths and more than 150 injuries. Among the victims were 3 highly respected storm chasers: Tim Samaras, his son Paul Samaras, and their colleague Carl Young. They were well known in the scientific community for their careful, data-driven approach to chasing storms, but the tornado's sudden change of direction trapped them on a rural road. Another storm chaser, Richard Henderson, also lost his life. Their deaths shocked both scientists and the public because these were professionals who had dedicated their lives to understanding tornadoes and promoting safety. The event underscored how unpredictable and unforgiving these storms can be, even for experts. Impact on communities. Despite the fact that the tornado traveled through primarily rural regions, it still caused considerable harm. Agricultural structures were destroyed, automobiles were thrown for hundreds of yards, and fields were left with scars as a result of the intense force of the winds. Due to the damage that was done to the power lines and communication infrastructure, certain areas of the region are currently without electricity. Tens of thousands of people living in Oklahoma City and the surrounding towns rushed to find a place to take refuge. The unfortunate reality is that some individuals attempted to escape the storm by driving their vehicles, which resulted in hazardous traffic jams on highways. Due to the fact that being stuck in a car during a tornado is one of the most perilous situations that can possibly occur. This mayhem brought to light a significant deficiency in emergency communication and preparation. Scientific significance. Despite the devastating outcome, the El Reno tornado gave scientists significant data that will aid in improving tornado forecasting in the future. This assistance would be provided in the future. Trucks equipped with mobile Doppler radar and storm chasers were able to take precise measurements of the tornado's interior structure, wind speeds, and growth patterns. By studying how a tornado of this scale can grow so rapidly and why it is still so difficult to predict its movements, researchers were able to gain a better understanding of these topics. The findings highlighted the need to collect data in real time and reaffirmed the requirement for more sophisticated warning systems. In addition, it brought to light the fact that the enhanced Fujita scale, which assigns a rating to tornadoes based on the amount of damage they cause, can overlook the actual force of storms that pass over areas with a lower population density. Lessons learned. The El Reno tornado changed the way both storm chasers and the general public think about tornado safety. For storm chasers, it was a sobering reminder that no amount of experience guarantees safety when facing an unpredictable storm. Many chasers now exercise more caution and avoid getting too close to large, erratic tornadoes. For the public, emergency officials stress the importance of not trying to flee storms by car, especially in urban areas where traffic can quickly become gridlocked. Instead, residents are urged to seek shelter in secure buildings, basements, or storm shelters. The tragedy also prompted further discussions about how to communicate risks more clearly during weather alerts, ensuring that warnings emphasize the potential dangers of unusually large or rain-wrapped tornadoes. Legacy today, the El Reno tornado stands as the largest tornado ever recorded and one of the most destructive weather events in modern history. While its size and wind speeds are what make it scientifically remarkable, its legacy is also tied to the lives lost and the lessons learned. It remains a case study for meteorologists, a cautionary tale for storm chasers, and a reminder to the public about the importance of respecting severe weather warnings. 10 years later, the event continues to shape how communities prepare for and respond to tornado threats, ensuring that the lessons of El Reno are not forgotten. The El Reno tornado of 2013 wasn't just the largest ever recorded. It was a sobering reminder of how small we really are against nature's fury. At 2.6 miles wide, with winds nearing 300 miles per hour, it will always stand as one of the most extreme weather events in history. So the next time you hear a tornado warning, remember, storms like this one prove that taking shelter isn't just a precaution, it's survival.